So today we're going to be covering factoring and also how factoring can help us when we are graphing equations. So buckle up, this is going to be pretty comprehensive for our class that I mentor for. I will try to be thorough and efficient. If you have any further questions after this video, please let me know. I will try my best to timestamp each section in the comments below. And with that, we'll just get right into it. So here we have this handy dandy chart. This was a chart that was made during class by our instructor, and she laid out some very nifty steps for factoring. Now, the first thing that we want to do for any factoring, be it quadratic formula, synthetic, Hippo Butts, and we'll get into that in a minute. Any type of factoring, you want to factor out the greatest common factor, the GCF. And you want to make sure it does not have a negative leading coefficient. So let's say you have the equation negative 2x cubed plus 6x squared plus 4x. We want to say, hey, what is something that we can divide all of these terms by that will make everything come out in an even way? We want to find what is basically what can we take out of this, so it's more simplified. So in this case, we can divide all three of these terms by an x, and we can divide all three of these terms by a 2. So we will take out a 2 times an x. One thing to keep in mind is that this is a negative 2x. We want our leading coefficient to be positive. Our leading coefficient is the variable with the highest exponent. We're going to take this and we're going to factor out a negative 2x, so it will make this positive. So now we have negative 2x x squared times x squared plus 3x plus 2. And this would be our factored out greatest common factor. It wouldn't necessarily be our finished factored form, but then we would be able to ignore this negative 2x for a little bit while we factor out this inside as if it were a separate problem. Once you're done factoring that, however, you want to add the negative 2x back in. That's something that I see people forget sometimes. For the second step, you want to count the number of terms. So say you have, so in our previous example where we had negative 2x squared plus 6x, we're going to change it up a little bit, plus 6x minus 4. In this problem, we want to say how many terms do we have? We have one here, another here, and one here, because they are separated, they are not like terms. So we have 3 separate terms. If you have 3 separate terms, what you can do is there are 2 different methods that you can do when you have the 3 separate terms, which is synthetic factoring and Hippo Butts. And we'll get into those in just a moment. If you have 4 terms, so let's say we have a 3x to the third. In addition to this, we have 4 terms. See, 1, 2, 3, 4. What we can do if we have 4 terms is, of course, we're going to split up the first. We're going to split up the terms. So we have into 2 groups. So 3x cubed minus 2x squared. So this is one group, and then we have 6x minus 4. And then we'll find the greatest common factor of those groups. So the greatest common factor of these here is going to be x squared. That will leave us with 3x minus 2. The greatest common factor of these are just going to be 2. That will leave us with 2 times 3x minus 2. And then what you can do is you find the greatest common factor of your groups. In this case, it's going to be 3x minus 2 altogether because it's in parentheses. So we can take that out. And what that turns out to be is we have x squared plus 2, and then we will have 3x minus 2. And that would be our factored form for that, if that makes sense. So like these two are grouped together, and then one of these is ours. So that would be factoring by grouping, where you split them apart. And it's for 4 terms. Now, if you count and you see that it has 3 terms, 1, and then 2, and then 3. If you count and it has 3 terms, what you can do, so there are 2 different methods. There's Hippo Butts and synthetic factoring. Now, again, for this, we want to factor out the greatest common factor, which is going to be -2 in our case. That will leave us with x squared minus 3x plus 2. Now, we can ignore this -2 for a minute. It still exists, but what we want to do is treat this inside as if it's a separate problem. Now, this inside has 3 terms. We want to check for a specific thing after we've, number 1, found the greatest common factor, and number 2, found that we have 3 terms. Now that would be, what is the coefficient of your leading term? In this case, the coefficient of your leading term is 1. That's important. That's the easiest, one of the easiest methods that we have, and it's something that we want to work towards. Now, if a coefficient is anything other than +1, like say you have 2x squared minus 3x plus 7, and you can't take out a greatest common factor, and the leading term coefficient is a 2, or anything other than +1, basically, you can do synthetic factoring. And if it's just a -1, as a side note, if it's -1 or -x, you can times the whole equation by a negative to switch that, and oftentimes it is worth it to do that. Now first, I will cover Hippo Butts. We're going to ignore that we took out the greatest common factor for now, just so we can make things simpler. We have x squared minus 3x plus 2. With Hippo Butts, for the future, there's another thing that is important to keep in mind, and it is the standard form equation. So standard form of a 3-term polynomial, standard form is going to be ax squared plus bx plus c. So in this case, our a is going to be 1, our b is going to be -3, and our c is going to be 2 in this case. When you are doing the Hippo Butts method, what you can do is you can take a and c, and this is the same for synthetic. So in both methods, you take your a and your c and you multiply them together. In this case, it's 1 times 2, which gives you 2. And then you want to factor out you want to find 2 factors that will multiply up to your c, that will also add to your b. So what is useful is to write out the different factors for your a times c, whatever you get for that. So in this case, there's 2 and +1, 1, +2, -1, -1, -2, and -2, -1. And all of these, when you multiply them together, will equal +2. Now, what we want for our Hippo Butts and our synthetic factoring is which one of these, when you add them together, will give you your b term. That in our case, our b term is -3. So we want this -2, -1, because -2 minus 1 is equal to -3. So we don't care about any of the other factors. We only care about -2 and -1. Now, with Hippo Butts, the reason why it's so easy is because you can draw out these Hippo Butts. I don't know how to draw a hippo, I guess, but here's your little hippo, and there's his tail or whatever. What you can do is you can take your x, or It could be other variables, like a y or something. Your x, or it could even be like x squared. We'll get into those cases in just a moment after I finish explaining this. So we have our x, and then we take one of our terms, minus 2, and then our other term, and minus 1. And this would be your factored form. This is all you would need to do if it was asking you to factor out 4x from this equation. This is our completely factored form. It's as simple as that. Now, if you have a coefficient in front, like say you have the equation 2x squared plus 10x plus 8. Actually, wait, that's a bad example. Hold on. Okay, say you have the equation 3x squared plus 10x plus 7. There's no greatest common factor here. We can't take out an x because the 7 does not have an x. We cannot take out a 3 because 10 and 7 are not divisible by 3, and so on. There's no greatest common factor. So we've done that. We've counted that there are 3 terms, and we know that the coefficient of our leading term is 3. It is not positive 1. So we can't do anything with Hippo Butts. We will, like I said before, we'll do the same process of timesing A by C. So we'll have 3 times 7, which is 21. And now let's list out the factors of 21. Let me hit that real quick. And then, so 21 is 3 and 7. And we want them to add up to 10. That can also be negative 3, negative 7. But 3 plus 7 multiply to 21, but add up to 10. So now what we can do is we can say, okay, let's take our a term and let's divide our a term by what we have now. So it's going to be positive 3, positive 7, and then divide by 3, divide by 3. And you still draw out some Hippo Butts, but in our case, what's going to happen is we're going to say, okay, here's plus 3, and plus 3. Oh, in this case, it's plus 7. And then we'll move our 3, our denominator, and we'll put that in the front. So 3x plus 3 and 3x plus 7. Or actually, I forgot to mention, we're actually supposed to reduce first. So we actually want this to be 1x plus 1. Because 3 over 3 can turn into 1 over 1. And so we'll move this plus 1 here and then this 1 here. My mistake. So this would be your factored form. And if you want, you can always multiply it out. You get 3x squared plus 7x plus 3x plus 7. That gives you 3x squared plus 10x plus 7. So that checks out. That is our factored form. And when you have your factored form like that, you can always multiply it out and see if you get your original, because then you will know it is right. Now, what happens if you have something like 3x to the 4th plus 10x squared? Again, there's no GCF here. But the thing is, if it's something like this, where you can multiply x squared, you basically want to worry about what's your term here, your degree of the middle term, of your b term. We would do the same thing, where we take our 3 times 7, 21, and we get our 3 and our 7, and you'd still do the exact same thing. The only difference is when we are putting it in our Hippo Butts. So we have plus 1 plus 7. Instead of 3x, we do 3x squared. And then if you multiply it out, you'll know that it will be correct. Now, say you had something like 3x to the 6th and x third. In that case, it'd be exactly the same, where we put a 3 there. Yeah, and always when in doubt, multiply it out. Anyway, so that is when you have 3 terms. So we've covered 4 terms, factoring by grouping, 3 terms, Hippo Butts, synthetic factoring. We haven't not covered 2 terms yet. So let's do that really quick. So for our 2 terms, I won't cover special cases because I know that this video is going to be insanely long as is, and you can figure out the special cases through synthetic factoring or Hippo Butts. If you want to know more about that, please let me know and I'll make a separate video on the special cases. for our two terms, well, moving on, for our two terms polynomials, what we want to do is so there's two different things, two different ways that it could look like. It could be like, let's just for simplicity say x squared minus 9 and x squared plus 9. These are two separate equations. We're not thinking of them as together right now. If you see x squared minus 9, you can think like, hey, we are looking for the perfect squares. So x times x will equal x squared, right? And 3 times, in either case, we don't necessarily want it to be equal to -9, but like 3 times 3 equals 9. It feels weird because it's not going to give you -9, but just hang tight and we'll go over that. It's actually, I feel like I think I prefer it better when it's -9. No, never mind. Ignore that part because I don't think that's true. But basically what you can do with that is, okay, sorry. The sum of squares is going to be sort of different. Let's see, push that aside for a moment. But if you have x squared minus 9, what you can do is you can say, okay, we have, in this case is our a and our c, a plus c and a minus c. And this is really nifty. They're called conjugate pairs. Conjugate pairs are when you basically flip the sign in the middle. So, if we have x squared minus 9, let me go in the white, x squared minus 9, how we would want to factor that is basically x minus 9, x minus 3 and x plus 3. Because in our difference of squares, we're thinking a squared minus b squared. And in this case, these would fit, but you have to remember that we have these squared, and so we want to square root them basically. So that 9 would be split into -3, and you'll see why once I multiply these out. So we'll have x times x, x times positive 3, 3 times -3 times x, -3 times positive 3. So we'll have x squared minus 3x plus 3x minus 9. And these plus 3x and minus 3x cancel out, so you have x squared minus 9. That's why you want it to be the square root, so you can have the squared terms in your a times your a squared minus b squared, like in your just sum of squares, difference of squares, my bad. The sum of squares is a little bit different, and I don't believe you'll need to worry about that for a minute, but if you had the sum of squares, what it would be is, and we talk about imaginary numbers, but I don't believe that you'll need to see these, or that you'll see these in this class. Maybe in 1050, but I don't believe so. But when you have a sum of squares, it's basically the same, where you have a plus b, a minus b, except for there's an I attached to the b. So it would be x plus 3i, and then x minus 3i. Yeah, I don't believe that you'll need to worry too much about that though. And then there are special cases. Like I said, I think I will skip over those for now, just for the sake of time. That covers the main idea, our main methods of factoring. However, there are, well, before like chapter 8 and a little bit of chapter 7, there are a few more methods that are also important for when you aren't able to use any of these methods, where it doesn't work out. And those two methods are completing the square and the quadratic formula. So when we are completing the square, let me find a good example for that. We'll get into some of the examples of completing the square and the quadratic formula in just a moment. First, I'm going to go over some common problems that you might see, and go through the strategies and solve them. So this first one, we have x squared minus 7x equals 18. Now, one thing that our first step is we want to find the greatest common factor. Now, there's we can't take out an x and we can't take out any other constants, like that kind of number. So it looks like there's no GCF. Whoops, GCF. Now we want to count the terms. There are 3 terms. Now we want to look for what the coefficient of our leading term is. And our leading term is this x squared. Our coefficient of our leading term is equal to 1. Equals 1. Positive 1. We'll do plus 1. That means that Hippo Butts is probably going to be something that's really great for us in this one. So we will do a times c, which is 1 times negative 18, which is going to give you just negative 18. Now let's factor this down. There's 2 and negative 9. And it looks like 2 and negative 9 will work because negative 9 plus 2 is negative 7. And that is our b term. So what we will do is we have our Hippo Butts. We have our x plus 2 and our x minus 9. Now let's check our answer. This should be our factored term. If you want, you can pause now. And here is the answer. Yep, it looks like we have that correct. Here is another problem. We have 2b plus 17b plus 21. Now, we are going to look for a coefficient. 17 is prime, and so we can't take out any constant type things. And 21 is, we don't need to worry about that. But there are no extra b's either. So there is no GCF. There are 3 terms. And the coefficient does not equal 1. Of our leading term does not equal 1. It's 2 right here. So what we will do is same process. 2 times 21 is equal to 42. 42 is, let me think of some factors for 42. Okay, so the factors of 42 are 2, 21, 6, 7, 3, and 14. And I bet there are probably others, but I don't want to go through all of them. 3 and 14 seem like our winning ticket. 3 times 14 equals 42, and 3 plus 14 equals 17, which is our b term. So what we'll do is we'll take our 3 and our 14. We'll divide them both by our a term, which is 2. Then we'll reduce when we can. So we have 3, and we'll be careful to note that it's plus 3 over 2 and plus 7 over 1. And then we'll draw out our Hippo Butts, and we'll have our plus 3 and our plus 7, and then our 1x and our 2x here. So bloop, 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 bloop. And so this should be our final answer. And, I forgot that we are dealing with b's and not x's. That was my bad. So 2b plus 3, 1b plus 7. And 1b and b are the same. So yeah, this is correct. Now we have, 3b minus 3b cubed minus 5b squared plus 2b. Now we want to look for a greatest common factor. And it looks like they all have b's, so we can divide by b, but there are no other constants. So we'll take out a b. That leaves us with 3b squared minus 5b plus 2. And so we found our GCF. It's a 3-term polynomial. And the coefficient of our leading term is not 1. So we are going to use synthetic factoring. We'll put the b aside for right now. And we'll say, okay, what's our a term? 3. What's our b term? 2. So we'll have 6. What are the factors of 6? Well, there's 2 and 3, and negative 2 and negative 3. It looks like that's going to be our lucky ticket, because negative 2 plus negative 3 equals negative 5. So we'll divide both of these by our a term, which is 3, and reduce when we can. So negative 2 over 3, and negative 1 over 1. And then we'll draw out our Hippo Butts. And that will give us 3b minus 2, 1b minus 1, or just b minus 1. And let's check our answers here. You can pause now if you want to finish. And here it is. So 3b minus 2. Oh, see, even I did it just there. I forgot to add the b back into our answer. And we need to multiply this by b, this whole thing by b, because we took out a b in the beginning. So yeah, I forgot that part. But yeah, we need to add the b back in. I didn't mean to erase the bottom part. Anyway, now you can see the answer. So for this one, we have 28n to the fourth, 16n cubed, and 80n squared. And let's look for our common factors. It looks like all of these terms are divisible by 4, and all of these terms have at least an n squared. So what we can do is we can take out a 4n squared. And that will leave us with 7n squared plus 4n, just 4n, minus 2, that's 80. 1 second. 80 divided by 4 is 20. So minus 20. Now, we found our greatest common factor. And we found that it's a 3-term polynomial. And the coefficient does not equal 1. So we'll be using synthetic factoring. 7 times negative 20 is going to give you negative 140. And we want to find terms that will add together, to 4n and multiply together to negative 20. So 140, let's see, there's 14 and 10, and it already looks like that's going to be our answer. We want a positive 4, so we'll make the 10 negative, and we'll divide both of these by our a term, and reduce when we can. So negative 10 over 7 plus 7 over 1, because it'd be 2 over 1, my bad. And now we'll draw out our Hippo Butts, and let's not forget our 4n squared yet. So 7n minus 10 times n plus 2. And you could multiply that out, and you would find out that you have the exact same thing here. And let's look at our answers. Let me zoom out. So 7n minus 10, n plus 2, 4n. Looks like we got that correct. Now we'll head up to here. This here will deal with the quadratic equation, so we'll skip it. This one, we will look for our greatest common factor, and it looks like k will be that. So we'll take out a k, and we'll get 7k plus 9. And that's actually all that you need to do. The answer for that is 7k times 7k plus 9. Those ones are really simple. This one will deal with completing the square. So we'll just go over that now. So there are some, well, let's pretend as if we're factoring for synthetic or whatever. We know that there's no greatest common factor here because they're just none are divided. Not all of them have an r, not all of them have something that's divisible by the same thing. So no greatest common factor. So in that case, and we also know it's a 3-term polynomial, and we know that the coefficient does not equal 1. So we'll have negative 90, and we want to say, what can we multiply to negative 90 that would give us, when we add it together, will give us negative 5. And long story short, there's not going to be anything. Just to save you the work. Instead, so when you've exhausted all of your methods, so synthetic and Hippo, when these are not available to you, there are fail-safes for when you are out of luck. When you don't get the easy method, there's always a hard method. And it's called the quadratic formula, or completing the square. But even completing the square has its faults. So I recommend doing the quadratic formula. Now, I will say, Serena has said that for this particular test, for the summer block of 2022, I can't promise you that it will be the same for any other people who are watching this video, that you will be given the quadratic formula. You will not have to memorize this. You will in 1050 if you are moving on to 1050, but if not, don't worry about it. But I'll give out the quadratic formula right here, and that is going to be negative b plus or minus the square root of b squared minus 4ac all divided by 2a. There's a song that goes along with it. I actually never learned it though, but it's like to the tune of the Mulberry Bush song, like da 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 da, that one, and I probably was very off key there. But what you can do is plug in your different terms into the quadratic formula, and that's what we're going to have to do for this problem. So we have our b term, which is negative 5, so negative 5 plus or minus negative 5 squared minus 4 times 9 times negative 10, all divided by 2 times a, which is 9. Now, we treat square roots as if they were parentheses. So now we will go PEMDAS in this little statement here, which is going to be 25 minus, I think it will be, I don't trust myself to do this in my head, so negative 4 times 9 times negative 10, negative 4 times 9 times negative 10 gives you 360. And in this case, it's going to be adding because we have a negative times a negative. And that will give you, to rewrite our equation, we have a positive 5 because it's a double negative, plus or minus the square root of 385 divided by 18. Now, if you remember in previous lessons, the way that we can simplify a radical is we can split it up into factors. So we have 385. We know that's divisible by 5, and that will give us 77. That's divisible by 7 and 11, which are all of these are prime. So we can't take anything out. So 385 has to stay in the square root. 5 is not divisible by 18. So this is going to be our answer. If you are in the program called My Math Lab, which is what many of my students use, you'll have to plug it in like this. 5 plus square root of 385 over 18, comma, 5 minus square root of 385 divided by 18. That would be your answer in that case. It's a very long method. If you plug this into your calculator, either one, where you plugged it in for your R, you will get equals to 0. And I forgot to mention that we would want to make this, set this equal to 0 to use a quadratic formula. So sometimes it'll be like plus 10 instead. You'll need it to be equal to 0 though. Or at least when we're solving for x, I mean. Anyway, so it's a really gross solution. It looks nasty. It's not something that's fun to do. It's not something that will give you fun answers, but it's something that will work. And that is our answer. Now we'll cover completing the square, which is similar to the quadratic formula. I think it's easier, or at least more intuitive to my brain. Oh, I need to hide the answers. It's more intuitive to my brain. I recommend it. However, if you have something like x to the 4th or anything more than squared as your leading term, it gets a little bit muddy. So I think that using the quadratic formula is very useful. A general rule is that the degree of your leading term, like 9x to the 4th, right here, this is how many solutions you will have. Some of them may be repeat solutions, but you will have 4 solutions if it is something like that. Which is where completing the square can get tricky. So we have this. There's not anything we can take out because not all of the terms have x, and not all of them are divisible by the same thing. So no GCF. It's a 3-term polynomial. The coefficient is not equal, the leading coefficient is not equal to 1. So we'll do, to save the time, I won't multiply out 9 times negative 56 and find all the factors for it. Just trust me when I say it's not going to work. It's not going to give us a nice synthetic factored answer. What we can do, however, is we can say, okay, we have 9x squared plus 7x, but we're actually going to move this 56 over. We're going to add 56 to both sides. We don't want anything without an x on one of our sides. So we have plus 56. So 56 equals 56. Now, what you'll do for completing the square is you will take your b term and you will divide it by 2. So b divided by 2. And then you will take that and you will square it. So in this case, it's going to be 3.5 squared, which is going to give you, I want to be sure with this one moment, 12.25. So 12 and 1/4. And whatever we add to one side, we have to add to the other because we want the value of the statement to stay the same. We don't want to change the actual value of our expressions. I forgot to mention we would want it equal to 0 on this side as well. Typically, when you will see something like the quadratic equation and completing the square, you will have an equals 0 on that side, or equals y, either one. So now we can add the 12.25 and the 56. That will give us 68.25. And what we did over here, when we added the 12.25, it seems weird, but what we can actually do is we can take that 7 over 2, and that will be an important thing for us. We will make it, so what you do, the thing that's nifty here is if you do 9 times 12.25, a lot of times you'll have a lot nicer numbers to work with. You'll have 110.25, and we can say that, wait a second, I'm realizing now that when you are completing this square, what you actually need is the coefficient of your leading term to be 1. So let me actually come up with a quick other example. We'll use the quadratic formula for that equation, and I apologize for the mix-up. One moment. Okay, so say instead we had x squared plus 6x equals negative 2. I forgot to mention that, and I'm sorry. Completing the square also only really works when you have 1 as your leading coefficient. Anyway, so now you'll do the same thing where you divide your b term by 2. So 6 divided by 2 equals 3, and then you'll square that, and you'll get 9. So you have x squared plus 6x plus 9, and whatever you do to one, you have to do to the other. So negative 2 plus 9, that gives you x squared plus 6x plus 9 equals 7. We can do Hippo Butts now. 9, 3, and 3. So you'll have, which is the same as your 6 divided by 2. So you have x plus 3, x plus 3, which is, or you could do x plus 3 squared, and then equals 7. And then what you can do is you can square root both sides. So you get x plus 3 equals the square root plus or minus the square root of 7. And then you will minus 3 from both sides. So you'll have x equals negative 3 plus or minus the square root of 7. And that would be your answer. Or in MATLAB, you would have to split these apart and do one with a plus and one with a minus. Okay, sorry for the mistake there. So to recap, completing this square, you take your b term, divide it by 2, square it, and then add it to both sides. And then you can go from there. It's it's really helpful for when you are trying to figure out the vertex form of a graph. Anyway, now we'll go back up to the quadratic one, and we'll just do another practice for this. And these ring true still. No greatest common factor. It's a 3-term polynomial, and the coefficient does not equal 1. So we'll take our b term, which is 7. So negative 7 plus or minus the square root of 7 squared, which is going to be 49, minus 4 times 9 times negative 56, which is going to give you, we're going to make it adding because it's negative 4 times a negative. So it will be plus 2016. We're going to add those together. 2016 plus 49 is 2065. So we'll have 2065 divided by 2 times 9, which is 18. And then we can't take anything out. 2065, you can try. It'll be 5 and 413. Whoops. And 413, I believe, is either prime or we keep factoring down and it still wouldn't be able to take anything out. So this would actually be our answer. And that checks out. This is our answer above as well. Apologies for mixing up the methods as well. So now this one is telling us to graph x squared minus 7x minus 18. And there are some important things to know when you are graphing quadratic equations. Whether this is a positive or a negative determines whether the graph is facing up or down. And I'm going to say that this is our axis because we have to deal with a negative 18, which is going to get big. This, our C term equals our Y intercept. Facing down. These are just some tricks that you can use when you are factoring your equations. Now we want it to be in, now what we can do is we can factor, and that will give us our x-intercepts. So what we'll do is, there's no greatest common factor, it's a 3-term polynomial, and the coefficient equals 1, so we'll do 1 times negative 18. What can we, and the factors are 9 and 2, and we want negative 7, so we'll make it a negative 9. We can do Hippo Butts, so x minus 9 and x plus 2. We want to know when x equals 0 on our graph, right? We want to know our x-intercepts, so we're going to set these two equations to 0. So x minus 9 equals 0, and x plus 2 equals 0. That'll give us x equals positive 9, and x equals negative 2. Those are going to be our x-intercepts. X-intercepts equals solve for x. Now, another way that we want to deal with things is we want to deal with the vertex form. And that's basically when we complete the square. The actual form is going to look like f of x, or y, is equal to x minus h squared plus k, I believe. And the way that what we can do to get it into that form is, so we have our x squared minus 7x plus, minus 18. We can complete the square. So we're going to move the 18 over. We have x squared minus 7x. Then we move the 18 over, so it's positive 18. Completing the square is kind of tricky for this one again. Oh, no, never mind. It's not. And then plus, so 3.5 squared, that was, I believe, 10 and 1/4. Let me just triple check that. 5 squared. And I'm getting the 3.5 because I'm dividing the 7 by 2. And then I'm going to square that. So I get 12.25. And we have to do that to the other side too. Which is going to be 18 plus 12.25 Oh, and I forgot to mention, we still have the plus f of x or y. We'll make it a y, so it makes more sense, I think. Let me get rid of this. So plus, and then, so plus y. And then we can factor this out. So x minus, let me remember. So it'll be x minus 3.5 squared. If you factor that out, you'll get x squared minus 7x plus 12.25. And then what you can do is you can move our 30.25, because 18 plus 12.25 equals 30.25. We want to move this over, so we'll do minus 30.25. And then if you're in vertex form, it's, and then equals y, and then that would be your equation. Or what makes more sense in my brain is putting it in front, or doing f of x equals this. And then what happens is your vertex is going to be your h and your k. So vertex is equal to, in this case it's going to be plus 3.5, because this was going to give us negative. I'll explain in a minute. Let me double check I'm right with that. Yeah. Whoops. So it's not like an automatically negative h. The reason it doesn't like turn it into h. We're just putting this into, no, sorry, my bad. It is still negative 3.5. I'm confusing myself. Sorry, it's getting late and this video is getting long, and I'm also sorry about that. It's almost an hour now. So what we can do now is our h is going to be our x, and our k is going to be our y. We flip the sign if it's in a parenthesis. So we have 3.5 comma negative 30.25 for our vertex. So this is our vertex. Another way to find the vertex is to go back up here, divide your b term, so negative b divide by 2, and then I don't think you square it. Let me double check. Okay, sorry. Negative b over 2a. Whoops. So in our case, it would be negative 7 over 2 times 1, which is equal to negative 3.5, or negative 3/2. And then what you can do, so your x value, here, hold on. Negative b over 2a, comma, and then you would plug that into your formula to get your y. I'm not going to do that with this one just for the sake of time, but you should get the 30.25 from that. Now for graphing, I'll put the intercepts, the x-intercepts. We know that we have an x-intercepted y and an x-intercepted negative 2. Because our graph is a little bit small, I'm going to say each of these, it goes by 2. So we'll do negative 2, and then the other was 9. So 2, 4, 6, 8, 10. It'll be right here. So these are x-intercepts. We know that our y-intercept is negative 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2 is 18. Here's our y-intercept. And we know our vertex is going to be negative 30.25. 3.5, comma, like for our x, and then for our y, negative 30.25. So 3.5. So 2, and then 3.5. It's going to be like right down here. It's going to be like right here. And then our 30.25 will be, here's 18, 20, 22, 24, 26, 28, 29. 30. And then 0.25 will be like right there-ish. And so they'll intersect here. Now, where this vertex meets, up and down, is going to be our axis of symmetry. It's basically where the vertex will go. It's where you could fold it over and it would be exactly the same on both sides. And then our graph should be symmetrical. Hold on, give me just 1 minute. So let me just get this right. I don't want to be too precise with this because I don't want to take up too much of your time. But basically, it'd be about right there. For their easier graphs, and I think the next one is an easier graph. Now let's check our answer. Yep, we have that about right. I think I messed up the original one. Yeah, whew. And so also you don't have to do all of this every single time. There are some patterns that you can look for when doing this that will make things easier. So personally for me, here I'm gonna we know our graph is going to be pointing downward. We know that our y-intercept is going to be +3. 1, 2, 3. And then I'll quickly factor it out. And I'm going to switch this whole thing into positive. So x squared plus 2x minus 3. Just for this, the facts of the graph still stay the same though. I'm just trying to factor it. So we get -3, 3, 1. And we'll say -1. So we have x plus 3. X minus 1, so our x-intercepts will be -3 and +1. So 2, 3, +1. And then for our vertex, what we can do is complete the square, and we're going to stick with this one because we want the coefficient to be 1. We'll move the 3 over, so we have x squared plus 2x plus, and then 2 divided, it'll be +1, equals +3 plus 1, which is going to be 4. This will turn into x plus 1 squared, and then we'll minus the 4 back over, equals y. So our vertex is going to be -1, -4. It's confusing to a lot of students that the inside of parentheses flips, but this one doesn't. It's simply because we're squaring. So that will change things. So if it's -1, oh wait, hold on. Just hold on. I think I've done something wrong. Oh, okay. I understand. I forgot to times this whole thing by -1. Again. And also, yeah, so this will turn into positive. This will turn into negative, I think. No, this will stay +1. Hold on, give me just a second to figure this out. Okay, I understand now. So once I factor this out, this whole thing turns negative, except for this stays positive. And so what happens is, we still want the vertex equals sign, is this will, I think this will distribute. No, it's just going to stay negative because our graph is upside down. My bad. Okay, so it's going to be, oh, but it's -4 though. 1 second. Okay, I just was getting lost in the math for a minute. I figured it out. So what we did is I moved the 3, I wanted to move the 3 over first, so I -3 from both sides. And then I factored out a negative from the whole equation so the value doesn't change. We want it so we just wanted to have the same value throughout. So then we completed the square, so we divided the 2 by 2 and then squared it, which is 1. And then we added 1 to the other side because it's whatever you did one side, you have to do the other. And then we still have this negative throughout, right? And then we move the 4 over, so -4, and then we still have like equals. And then we distributed, so we have x plus 1 squared, negative x plus 1 squared plus 4, and then we still have, and then we have our y, our function. Yeah, so what we can do now is we can say our vertex is going to be -1, comma, +4, because it's going to inverse on the inside of the parentheses, and then it's going to stay the same there. So our vertex is equal to -1, comma, 4. So we'll go -1, and then up 4. And then this will be our line, our axis of symmetry as well. Which is to say, if you flip it over on its side, it will give you what you need. And so we'll put one there, and then that's really all you need to know. You can make a graph there, and the answers, I did the answers wrong, so I'm not going to show, but if you put it into Desmos, it will give you something like this. Whoops, like this. Now onto circles. I'll try to be quick. Let's see if I can fit it into the 5 minutes. So this is just an hour-long video, and I'm sorry about that. So what we can do is, for these, basically, our format is going to be x minus h squared plus y minus k squared, equals our radius squared. So to find our radius, all we have to do is, once this is in the correct format, square root our r term, which is going to be, in this case, 2. Our radius is going to be 2. If it's just x squared plus y squared, there's no h and there's no k. So our radius is, our origin is going to be 0, 0. And then to draw, we'll just do 2 points on the outside and connect the circle. Now, that part's easy, like enough to think about, especially if it's something like this, and it's already factored out for you for the most part. But there are going to be equations where you get something like this, where it looks very, very intimidating. But there are ways to get through this, and we're going to be using factoring by squares with this one as completing the squares with this one as well. So, and we can't factor by grouping necessarily because we have an x and a y in our answer, and that will change things. So we'll move the 16 over. So we have x squared plus, and I'm going to make it so the x's are together. So x squared minus x, 8x, sorry. And I'm going to leave a gap for a plus, and then plus y squared minus 6y, I'm going to leave a gap for a plus, equals negative 16. Now we're going to complete the square. We divide this 8 by 2. That gives us negative 4. Negative 4 squared equals 16, positive 16. So add 16. We'll add 16 over here. And then for this one, divide this by 2. We get negative 3. We're going to square that. We're going to get positive 9. Add 9. These 16s cancel out, so we have a 9. Now what we can do is we can take our divided by 2 term, and that will be our what we'll put in. So x minus, which is just going to be 4, and then squared, and then plus y minus 3 squared equals 9. And our radius, we'll square root this. We'll get 3 for our radius. And our origin is going to equal positive 4, positive 3. And we're going to flip the signs of these because they're inside the parentheses and being squared. Now to graph that, we'll find our origin first, which is 4, 3. So 1, 2, 3, 4. 1, 2, 3. Right here is our origin. Our radius is going to be 3. So we'll plot our points, connect them, and that is what it should look like, yeah. So we have that correct. Yeah, I'm going to try and connect them a little better maybe. No, I had a circle tool that I could help with that. Okay, that is the video. It was an hour long, probably 30 minutes longer than I wanted it to be, but it's a good starting point, I think. The best thing that will happen for you is just to practice, practice, practice. If you have any questions, please let me know. And yeah, have a good one.